Okay, let's look at this problem here. We're going to find the normal stress in AD, BE, and CE. The cross-sectional area of each of these members is 450 millimeters squared, and we have A992 steel. Alright, the problem about this one is you cannot find out what the force in BE and CF and AD right off, because if you sum the forces in the y direction, you're going to get three unknowns. If you take a moment around, say D or any D, E, or F, you're still going to get two unknowns. So we'll go ahead and write the equations that we know right now. So what we could say would be we could sum the forces in the y direction and set them equal to 0. We would get AD minus 50,000 newtons plus BE minus 80,000 plus CF minus equal to 0. We could also take a moment around any of these points, but we'll just pick D. If I take a moment around D, I will get minus 50,000. Anything that goes clockwise is negative. Times the moment arm is 1. Plus BE times 2. Minus 80,000 times 3. Plus CF times 4. And we can set that equal to 0. But again, if you look through here, we have three unknowns. 1, 2, and 3. But we have two equations, so it cannot be solved as stated. Okay, so first thing I'm going to do is I'm going to draw a Freebody diagram of the DEF beam. And when I do that, it should look something like this. You got FAD coming up, you get the 50,000 coming down, FBE coming up, 80,000 going down, FCF coming up. So we'll go ahead and draw an arrowhead on there. And that's basically my Freebody diagram of this beam. Alright, so now let's look at this beam where I have the deflection shown. So the red here represents the deflection of the beams as after the load is applied. Now there's something unique and something important to catch here, that this beam here, even though I've deflected it more than what it actually would, is nothing more than a straight line. So what you want to do here is try to find out what the slope of this line would be. Now slope is defined as change in y over the change in x, or the rise over run. So what we need to do is find out what this distance here is going to be. That's going to be my rise. So isn't that distance going to be nothing more than deflection at CF minus the deflection of AD? That would be this change. Now if I divide it by this total distance, I'm going to get the slope of the beam itself. So that's your slope of the beam. Alright, so now let's see if we can write some equations. If I'm going to find the deflection at CBE, could I not say the deflection at BE, I shouldn't say CBE, at BE is going to be this total deflection. Now this deflection from here to here is just AD. Plus the slope of a beam. If I multiply the slope times 2, I will get this distance. Again, so there's my m value, and then all I have to do is multiply that by 2. Because again, you're basically doing y equals mx plus b, where b in this case is going to be the deflection of AD. That's like your y-intercept. This is going to be your slope, and this is going to be your x value. Alright. So now we're going to try to get an equation from this and then be able to put that back into our summation of forces and summation of moments and eliminate one of the unknowns. So can we not say that the P, basically we're doing this, right? PL over AE is equal to deflection. So can't we say that the force of BE times the length over AE is going to equal to the force of AD times L over AE plus this. And let's simplify this. Isn't this just going to be 1/2 times, in parentheses, and now we'll go ahead and do this, FCF times L over AE minus force AD times L over AE. So we have that. Now let's just simplify, because we can simplify the heck out of this. The lengths are all the same, so lengths are gone, lengths are gone, lengths are gone. The areas and the value of E is the same for each. Alright, so now let's see what our equation is going to be. So now, do we not have this equation here? FBE is equal to the force AD plus 1/2 FCF minus 1/2 FAD. So now we can simplify. FBE is going to equal to, we'll subtract these two, that becomes 1/2 FAD plus 1/2 FCF. Now let's extend this down, give ourselves some more room, and then we could just make things a little cleaner. We could use this equation, but we can also say that 2FB is equal to FAD plus FCF. Now let's go back to our earlier one and let's grab these equations here. So grab this, and we're going to bring this over and then solve. Scroll all the way down, give myself some room. And okay. Alright, so now look what we have here. We have three equations. This equation here. We have this equation here. We have this equation here. So now we're ready to solve because we have three equations, three unknowns. So it really doesn't matter where you start. Okay, I went ahead and corrected this. This should have been FBE instead of just FB. Alright, now we can substitute back in because we do know this. The first equation, I'm going to rewrite it a little different. I can write it as AD minus 50,000. I have BE here, so I'm going to replace that with 1/2 FAD plus 1/2 FCF minus 80,000. Now this is CF. I'm going to write this as now as FCF. Again, I should have been more consistent, but I think you understand what I'm saying. Now we'll do the second equation. I have minus 50,000. Now this is 2BE, so we're going to replace that with just FAD plus FCF. And then we got this. I might as well do the multiplication. That would be minus 240,000. Plus 4 FCF equals 0. Notice we have two equations, two unknowns. This problem can be solved. Let's go ahead and see if we can simplify everything, make it look a little cleaner. And I may choose to do this with matrices. Right now I don't know for a fact I'm going to do that. We're going to take the 50,000. We're going to add it to the 80,000. Getting 130,000. So let's rewrite this first equation to make it better. And I should have made this an F2. Again, not being very consistent. 3 halves FAD plus 3 halves FCF. I'll move all this to the other side is 130,000. Okay, I'm going to multiply everything by 2/3 to make this equation just even better. That gives me FAD plus FCF is equal to 86666.67. All right, let's see what we can do with the bottom equation. That would give me, so let's go ahead and circle this too. Hang on to this one. Let's take the bottom equation now and rework it. Minus 50 plus that gives me minus 290,000. FAD, I got one of those. Let's see here. How many FCFs do I have? Or let's see what I got here. I have FCF and that. That gives me 5 CF. Okay, let's clean that equation up and then we can probably solve this problem. So we can make that into FAD plus 5 FCF is equal to 290,000. Let's take this equation here and put it right below it. Okay, we got two equations. We could go ahead and just going to multiply this. So let's or subtract this. Let's make this a negative, make this a negative, make this a negative. Let's add those together. That gives me 4F CF. Now 290,000 minus gives me 203,333.33. We'll divide that by 4 and we should have the force in FCF. FCF is equal to 50,000. 833.33. Then we can get FADF right here. We're going to take 86,666.67. We will minus that one, and that gives me 35,000. Supposed to be 35,000. Okay, and then you just basically you keep going on up and find the other force. To find the other force, then what we would do is just go back up to the summation of forces equation right here. You would put in what you know from this one down here. Now we know AD and CF, so we can find BE here. If you just put those values back in, I think you'll find that the force of BE is going to equal to 43,333.33. Alright, so now let's just go back to our let me go back to the picture because I would like to know what the unit. Okay, kilonewtons. So we're doing great. We got it all into newtons. I should put that in there. Newtons. Alright, so now it's real easy. We just need to find out what the stress is going to be. So the stress at AD, we'll do that real quickly, would be the load. Get rid of that mark here. Would equal to 35,833.33 newtons. We will divide that by basically the area that, let's see what the cross-sectional area of that thing was real quick, 450 millimeters squared. I'll extend this down. Now I'm going to let you do the conversions on this to get it back, but that will give you roughly about 700, around 79.6 megapascals. You'll do the same thing for the other ones. The stress at CE or CF, sorry, 50,833.33 divided by 450 millimeters. And again, you're responsible for doing the conversions. And when you do that, I believe that gives you around 113 megapascals. And your final one is BE, 43,333.33. Divide that by the cross-sectional area. And again, make sure your units are correct. And when I do that, I think I get something like 96.3 megapascals. Okay, I hope that video helped you understand how to do a beam like this when you have 3 deflections and you have 3 unknowns. Best of luck.